All right, we are going to go over this intervention handout for covalent bonding and electronegativity. So you will want to have your periodic tables and also your prefixes for your covalent naming and writing. Okay, so for the first part, we're looking at electronegativity, which electronegativity is the ability of an atom to attract a shared pair of electrons. So this idea is really centered around covalent bonding, which involves sharing electrons. So electrons can either be shared equally, meaning they're right in the middle of two different atoms, or they can be shared unequally in this situation where the pair of electrons is going to be closer to one atom than the other. And that is what we call a polar covalent bond. Okay, so we use electronegativity to figure out if a bond is going to be nonpolar, polar, okay, which both involve sharing, and also both involve nonmetals with other nonmetals or metalloids, or if that bond is going to be ionic, which if it's ionic, that means that the electron is going to be completely transferred over. And we know that metals want to lose electrons, and we know that nonmetals want to gain electrons. Okay, so that whole concept there is explaining what electronegativity is. Now, we use a chart to figure out what type of bond is going to happen. So our difference chart over here shows that if it's between 0 and 0.4, it's going to be nonpolar. If it's greater than 0.4 and less than 1.8, it's going to be polar covalent. And then if it's greater than 1.8, it's going to be an ionic bond. So you do not have to memorize these numbers. Instead, you need to just calculate the difference in electronegativity. And so you'll just take the difference and you'll make it a positive value, which is the absolute value. So in this first example, we have Na with Br. Now right away, you might notice that Na is a metal and Br is a non-metal. So for many students, they can see that and know, well, that's going to be ionic because it's a metal with a non-metal. But we can also calculate the difference by finding Na at 0.9, and we can find bromine at 2.8, and then we can subtract that number and make it a positive. And then we're going to look up here at this chart and see that it's greater than 1.8. That means it's going to be an ionic bond. Okay, I did the same thing for these examples as well, just subtracting their numbers from my table and then taking that value, finding it on the chart, and then determining what type of a bond it is. On the back side, we're now looking at covalent bonding and how to name and write formulas. So you do want to use your flow chart and your periodic table to help you with this section. Okay, so when we are trying to figure out the name, we need to first look at the first element listed. So in this case, we see that it's chlorine. And then we're going to notice that we have 2 chlorines. So because I have 2 chlorines, I need to use my prefix for 2 and add a di in front of chlorine to indicate I have 2 chlorines. Then I'm going to look at my second element and notice that it's oxygen. So if I have oxygen, I need to change my ending, which is ygen, and I'm going to add IDE. So that's going to become oxide. And we need to do that with all of our second elements. So we just take the root of the word and we change the ending to IDE. Now, because I only have 1 oxygen there, I'm going to use the prefix mono, and then I'm going to have oxide. So that is why for number 1 there, I chose E, which is dichlorine monoxide. Okay. For the second one here, again, I have only 1 oxygen, So I'm just going to say oxygen. I'm not going to use the prefix mono because we already know there's only one. And we don't use mono for the first element. My second element is fluorine. So if I have fluorine, I'm going to change my ending to fluoride. Now I have two of them, so it's going to be difluoride. And that is why I chose C as my answer. Okay, so you're going to do the same thing for 3 through 6. So given that you have the name options, it should be a little bit easier for you to figure those out. Now, when I give you the table and I give you the name, now I'm asking you to do the opposite. So we're going to reverse. So looking at our name, you want to first look to see if you have a prefix. So on my first element, I did not have a prefix, so that's how I knew I only had one. For my second element, my prefix was tetra, so tetra means 4. When I write my chemical formula, I'm just going to write the symbols for each of those elements, and then I'm going to write down the prefix number that I just figured out in those second columns there. So I had 1 carbon, and I do not have to write 1, and I had 4 iodines, and so that's why I wrote 4. All right, so you can see how I did those next 2 examples right there. For number 8, we're now looking at our formula, and we're writing down the name, and this time I'm not giving you a word bank. Okay, so for first I have chlorine, and there's only one of them, so I'm just going to say chlorine. I did not say monochlorine. For the second element, I have 3 of them, so I'm going to use the prefix tri, and then I'm going to change my ending to IDE, so it's trifluoride. For B, I have 2 of my P's, so my P is phosphorus, so I'm just going to say diphosphorus. My second element is Br for bromine, and 4 means tetra, so I'm going to do tetrabromide. Okay, so all of my endings are going to be ending in ide. And then for the last section down here, we're taking our name and we're writing our formula. So if I only have 1 of them, I'm going to write just my symbol, no 1, just the symbol. And then looking at dioxide, I can see I have a di. Di means 2, and I have 2 oxides, and oxide is short for oxygen. So that is how I got CO2. All right, so hopefully you can use your flowcharts, periodic tables, and you can look here at the answer key to feel better about the Notes 1 section.